Hello, my name is Alisa, and in this project for the course, I built a machine learning model to predict the electrical energy output of a power plant using environmental sensory data. I will walk you through on how I framed the problem, trained the model using Google AutoML, and evaluated the final results. Since the target is a number, I will use a supervised regression. I will identify it as a supervised regression problem. The input features I use are temperature, ambient pressure, relative humidity, and exhaust vacuum, which are all environmental readings from the power plant sensors. I use root mean squared error as a main evaluation metrics because it highlights large prediction mistakes, which is important when working with power output values. In addition to this, I also use mean absolute error to measure the average prediction error in megawatts and error squared to evaluate on how well the model explains changes in the power output. Those metrics together give a clear picture on both accuracy and overall model fit. So for the model training, I use Google Vertex AI AutoML for tabular data. I choose AutoML because it does require writing a code, and it automatically tests different algorithms and hyperparameters to find the best model. I uploaded the data set, selected regression as a task, and set P as a target variable. So all sensor ratings were used as input features, and I used the automatic data split provided by Vertex AI. Vertex AI automatically split the data into training, validation, and test sets, where the training set is used to build the model, the validation set is used to compare them during the training, and the test set is used only for the final evaluations. To compare performance, I trained two models with different training budgets and later compared their evaluation metrics to select the best model. To compare models, I trained two optimal regression models using the same data set and the same features, but with different training budgets. Model A was trained for 2 node hours, which allows AutoML to train more model architectures and hyperparameters. And Model B was trained for 1 node hour, which is faster, but it explores fewer options. Since everything else is kept the same, any differences in performance can be attributed mainly to training time and model search depths. I then compare both models using root mean square error, MAA, and error squared on the test set. So after the training, I compared the performance of two AutoML models using root mean squared error, mean absolute error, and the error squared, which also calls the coefficient of determination. So Model A performed significantly better with a root mean square error of about 3.3 megawatts and error squared value of 0.96, which means it explains about 96% of the variation in power output. Model B had much higher prediction errors, so I selected the Model A as a final model. Just to quickly compare, within the Model A, we have root mean square error of 3.3 roughly megawatts, and for the Model B, we have much higher number, which is almost 54 megawatts, which is a huge difference. So this aligns pretty well with how our power plant efficiency works. But also another thing that I forgot to mention that I I also analyzed the feature importance, and the temperature was the most influential factor, followed by exhaust vacuum, while relative humidity had the small, and together with the pressure had the smallest impact. So basically, this kind of aligns well with how power plant efficiency typically depends on environmental operating conditions. So, in conclusion, I was able to successfully build an accurate regression model using Google AutoML and Vertex AI. The selected model achieved low prediction error and a high R squared value, which shows that it explains most of the variations in the power output. The results are also show that the temperature is the key driver for the performance, and is which matches real world expectations for power plant performance. So the overall, the project demonstrates how automated machine learning tools can be used to build reliable predictive models without manual coding. Thanks for your time.